my name is Jakub, and I'm here to talk about the love triangle that exists in wireless networking. So, who am I? I am Jakub. I'm part of the Meraki escalations team. I've been part of the Meraki family for over 8 years. I'm from Poland. If you ever do an AP on a stick and you're missing poles, me and Mark charge by the hour, call us. I'm a father. I do like fishing. I have a dog. I have a toddler, as you can see by my face. He's very active. And what we're going to talk about today, so we're going to focus on 3 things. We will identify the key relationships that exist in the wireless networks, okay, that we need to take into account whenever we design it. We're going to define everyone's different responsibilities to maintain those relationships. And I'm going to show you a couple of real-life examples where things can go bad if you're being creative. Before we get started, whenever we do site surveys, we always measure for the RSSI, right? We always measure for the coverage. We usually use some nice tools, and the moment everything's green, for a lot of companies that do those site surveys and provide those services, it's job done, right? But a good performance is more than just a coverage, right? It's all about how quickly we can get customers and client devices onto the network, how quickly that they can actually authenticate. Then we looked into the performance metrics of how quickly they can roam, is there a latency, is there any packet loss, what kind of SNR do they get? And then we also need to monitor the infrastructure services, DNS, DHCP, radius, right? Because as Keith said multiple times, it's not always a Wi-Fi problem. So what happens if your end users actually fall into those buckets where they are unable to get onto the network or they experience packet loss? Well, according to them, Wi-Fi sucks, right? And they're not going to be happy. So you can have 400 devices being all happy and having the great experience. Those 3 guys will be your nightmare. So the love triangle is very simple, right? On this picture, we have 3 key relationships for which we need to design for. The first one and the most important one is AP to client, all right? This is a downlink relation that actually dictates how the uplink operations will work, right? That, from the perspective of the client, is how well I can hear it. This is exactly what we site survey for, okay? And how well I can hear the infrastructure actually reflects with what data rates I can use, how quickly I can move around the network. The other relationship we need to take into account is client to AP. That, in opposite way, actually dictates the downlink transmissions, right? How well AP can hear a client will decide what data rates we can use, right? Of course, in enterprise networks, we have more than one AP, hopefully. So we also have to think about the roaming, how we play around with other devices, part of the same network. And the last but not least is the AP to AP, okay? And this is your wireless relationship with your APs that you own, right? Why is that important? Well, your RRM lives there. Your key management lives there, right? Any other control plane is exactly what we need to consider when we design massive scale networks. And we also have to care about our neighbors, right? So there's not many environments where you will deploy Wi-Fi and there's nothing around it. There's always someone in there, okay? So let's look into those in a bit more detail and see what kind of roles each one of those devices actually play to have a nice and smooth wireless experience, okay? So AP, as far as the relationship is concerned, is the one wearing the trousers, okay? The AP is the one that's usually mounted somewhere on the ceiling above the users, so that means it can hear a lot of things, right? It will hear not only what's happening within its coverage, within its cell, it will also care about what happens, you know, in other cell sizes, right? What happens from the perspective of other neighbors. He needs to make it work for everyone, right? AP is the control freak, right? It's your ex-boyfriend, girlfriend that wants to read your text messages. It wants to tell you what data rates you want to use. Good luck with that. It wants to tell you when you should roam. Good luck with that. But it wants to control everything, right? But when the AP is around and when it communicates, it has to be the nice one, right? It must obey by the same rules as the client devices, right? It has to win access to the medium before it can send anything. What are the main things about an AP? Well, it's highly customizable. And this is 99% of work for everyone in this room. We can control the TX power, the channel assignments, the data rates, okay? And this is the key and the foundational config that we should focus on. We have more advanced options like RxSOP, 11K, 11V, but a wise man once said, and I cannot quote, I don't know who it was, I just overheard it in one of the conferences, don't do in software what you should do with proper RF engineering, okay? And I think it makes sense. The second one is the client. Client is the submissive one. Client has to obey by whatever AP tells it to do, right? What do we know? It's a less powerful device, okay? The size of the antenna between client and access points differs a lot, right? It doesn't hear what's happening, 20 meters away from it. It only cares what's around it. That's why hidden node problem is a big problem, because it can only hear the communications towards the AP. If the client is on another side of the AP, it won't be able to hear it, all right? As Tobias was mentioning, power save mode dictates the operations, right? We've had so many instances where clients were not having good performance only because they were disconnected from the power cable. Or the power cable was not working, right? And it's specific to devices that say they do MIMO, that have multiple spatial streams. Well, the moment you disconnect it, the likelihood of you using more than one, yeah, have fun. It's not as customizable, okay? Unless you're running a Linux box where you can control everything you want. iPhones, Samsung devices, Windows laptops, MacBooks, they come with a preset criteria, what they use for roaming, what they use to select a good candidate. So with that said, we have to heavily rely on a good documentations from the vendors. The final thing that's most important about the clients, they decide when to roam. We would like to think we can control that, but it's still up to them, right? So here's an example, and I think it's already came up today, of an Apple documentation that's really well written. It defines when the device will start scanning, when it will roam, what kind of APs it will look for, whenever it makes those decisions, right? So if you have something like that, it's very easy to come up with a good design, and you will get it 80, 90% right at this point. The last relationship and roles are the AP to AP, all right? And some of the APs that we will have to play with are part of the family. The other ones are noisy neighbors. Regardless of that, AP that we own has to make it work with everyone, regardless whether they like it, regardless whether they don't like it. And there's two types of communications there's two types of links over which that relationship is being developed and established. The first one is over wireless, over RF, right? And this is where we need to listen how well we can hear the APs from our networks to come up with RRM settings. Same, we need to control constantly how well we can hear the neighboring networks, because they will interfere, and we will see in a couple of examples later the impact of that. Over wire is also something that we tend to forget about, and it's very important, right? Every vendor has different technologies, and what is that communication over wire? Where this is our PMK distribution, right? This is our exchange of data about the client's devices to make 11K, 11V decisions, right? And there's probably more, right? Every vendor does it differently. So, it's probably not as important when you deploy a network up to 50 access points, but when you go beyond 400, 500, it's probably good for you to spend some time to digest those vendor documentations so you know the scale and you know some of the potential problems you may be running into. Okay, so let's put that theory into practice. So RSSI directly impacts the performance. Do we all agree? Yes, no, maybe? It depends, right? RSSI is the first thing that the device will pick up, okay? And high RSSI usually means high MCS, okay? And don't kill me, I'm gonna explain. High RSSI is what the devices will use to decide, okay, how well I hear the AP, to decide what data rate I can use. On top of that, we have the noise to come up with the signal-to-noise ratio. Then we, of course, have to win the contention, so it can take a lot of time. And even though we can use the most sophisticated modulation technique that exists out there, if you have to wait a couple of microseconds more to access the medium, it's not going to be a great experience. So yeah, high RSSI, good MCS is usually the logic. A well-designed network should aim for one thing. It should aim for an AP to hear the client at the same RSSI as the client hears the AP, okay? And why is that? Well, that will give us a consistent data rates throughout. How many of you have done a speed test and you saw that the downlink was 20% less compared to an uplink? Yeah, exactly. So let's look at an example, not from real life. It doesn't exist most of the time. You have client A hearing the AP at -51, client B at -66. And according to an AP, this is how it hears the devices as well. So -51, -66, everything will work. In real life, things don't work that way. You take your phone, you put it next to your head, you get -15 immediately, all right? So that's why it's important for you to also understand how those devices will be used. And just because of that, because of the dynamic nature of end users and how those devices are being exploited, you won't be able to get it 100% right at all times. RSSI imbalance may result with frequent downshifts and retries, and this is bad, right? We will cover that in a second. From the experience, I usually see a difference of between 6 to 15 decibels, right? The latter number, the 15 decibels, I usually see that 80–90% of the time, to be honest with you, right? So now let's look at how people can get creative, right? Because they're unhappy with -66, they're sticky, they think it will suck, all right? So we have a unhappy user, -66 sucks, let's see what we can do about it, right? So next thing that user does, speaks to an IT guy who knows not much about Wi-Fi, and it sees that the TX power is set to 14 decibels, okay? So then they go onto the management platform and they decide to get creative and set it to maximum transmit power because the highest, the best, right? So what happens, right? We set it to 30, of course that config won't be accepted because we have to take into account the antenna gain. And so we increase the TX power by 10 decibels and we can see client A is now switching to 41. Client B is switching to 56. From the perspective of access point, nothing changes, right? It's still the same RSSI. So what happens next? Well, I'm getting -56, but my initial experience is really bad. Why? Well, because of this, right? I'm getting a false feeling that I'm getting an amazing signal strength. I must be very close to an AP. I'm going to use the highest data rate I can use, and nothing happens. I'm not getting an acknowledgement back. So I'm going to try multiple times. Nothing happens. I'm going to downshift. Nothing happens. And then we can see that eventually it did got an acknowledgement back. Okay? Every time one of those happens, those retries, what happens behind the scenes? Contention window gets bigger, so it takes more time for us to access the medium. Also, something else happens, and I forgot. Once it settles what data rate it wants to use, it will continue to use that, right? So we're only talking about bad initial experience for the end users, but then once it settles on a data rate that works, it should work most of the time, okay? If we don't have pickups available, and sometimes it's difficult, right, to capture at the right time, we do track a lot of metrics, right, from the performance of the end user device. So we can look at metrics like the average latency, the channel utilization, how many client devices were connected to that AP, and also the data rates, right, to do some retrospective troubleshooting as well. Another creative way of making data rates not work really well is putting APs away from the end users. So whenever I get a case or an escalation, what I always like to review is the existing RF profile and what are the TX powers actually configured on those APs, right? So over here you see the range is between 8 and 17. Nothing wrong with that. It looks really well. But we see all of the APs using 8, right? So the lowest from the range. To me, as a wireless engineer, what it says is we can hear, from the AP perspective, we can hear each other so well, we want to go down, but because of the transmit power plan, we cannot, right? So blindly, you know, a junior support engineer will say, okay, let's go to 5, let's go to 2. We don't care. Be careful with that. You should always validate. Why? So this is the network where everything was on 8. As you can see, the APs were placed nicely in a hallway, right? Away from the end users. I happened to be in that meeting room 140, and I kid you not, the moment you go inside that meeting room, you get -20, -25, right? Triple glazing, 5 centimeters solid wood doors, metal walls between the meeting rooms, massive telepresence units. It's just not built for RF, right? So then we looked at the site survey. The strongest AP we were able to hear was -64. So if we were to blindly suggest, let's reduce the transmit power plan to make RF better for the APs, yeah, clients will complain, right? And I would have to travel to that site multiple times. So a quick maths to see what the end user's experience would be in that room. You take the RSSI reading, right, -64. I would probably take -71 myself. I would always aim for the worst case scenario in case that AP goes down. Then you offset the device that you're actually using because, as you can see, that was measured. And we get bad user experience, right? Bad TX can also cause a capacity imbalance in your network, right? And I think that was one of the unexpected features that Matt was talking about at the beginning of today's conference. So these days, most of the APs that you will play with are tri-band, right? We're not going to go into 2.4, but 5 and 6, right? Two most common setups, 5 and 6 or dual 5 gig. A lot of customers I play with or work with these days, they're not ready to go 6 gigahertz. They're not brave enough. They don't think they have enough devices that will actually benefit from that. So they go with dual 5. What's important is that we need to think about the actual coverage of the cell, right, when we deploy dual 5 gig. We make sure to reduce the interference between the two radios by separating the channels by at least 100 megahertz, which is nice. But when we designed for 2.4 and 5, we came up with -7 decibels to make sure the cell sizes are the same, right? So that the client will always end up on 5 gig. Well, we need to take into account the antenna gain and the antenna pattern. So in front of you, you can see the polarization pattern from CW9166i from the 5 gig radio and the flexible radio, right? That can act as 5 and 6. With the directional unit, the flex radio on 6 gig has higher antenna gain, which is the unexpected feature that Matt was talking about. On a 66i, it's the same. So if we do an overlay, we can see that the patterns are actually different, okay? So what does it tell us as a wireless engineers? Well, we can sleep nicely because the radiation takes care of balancing clients between the radios nicely. Well, some of the customers I play with, they are very creative and they just won't listen. Where we have this config, and this is what happens. And guess what? Wireless is a shared medium. So devices on channel 36 will have completely different experience to those on 104, okay? There's one more thing. We're never alone, right? So if we go back to that example, APs, clients on channel 36, clients on 104, on top of that, if you throw in neighboring networks that are on the same channels as you are, right? So all of the ones in yellow are the networks that are not managed by my customer, okay? This is anything around it. As you can see, Uni1, 80 megahertz, right? So in UK, we're almost out of options for non-DFS. And we end up with a borrowed situation where we try to play it nicely with the customers, but they're being, with our neighbors, but they're being pain in the back, okay? We can get creative. We can try to go to Uni3 because we can hope that the customer solution doesn't support it. Also, some people don't want to use Uni3 because their client's devices don't support it as well, right? So it's quite a tricky situation. What does it look, how does it look like in real life, right? If you actually look at the packets. So we can see the utilization, right, is quite high. Whenever the customer client devices transmit, right, on the same medium, utilization goes up. At the same time, the retries go up, right, because they cannot send the data frames or they cannot win the contention. So it's not a nice place to be. But with the right tools, and this slide is sponsored, I was forced to do that by Matt. With the right tools, once you do a site survey, you can quickly see the health state of your network, what is the primary coverage, blah, blah, blah. I think my favorite is actually this one for someone who doesn't have a lot of time, right, to go through the config and stuff like that. They just did a site survey. It's quite nice that we can get some insights as to what config options the customer should select. I did ask Matt what is his favorite part about this feature. Well, he said apparently it's the best thing that happens since sliced bread. So I don't know. Yeah, I don't know. But yeah, Also, depending on what vendor you use, you probably have a lot of insights available on the management platform that you have, right? So over here, we can see the neighboring APs. We can also switch it off to see anything around us, so OBSS. And we can try to make some data-driven decisions to make it work nicely. I'm about to finish. I have a few more slides. So client devices, right? That's the last relationship. That's the most important relationship because we can have an amazing channel plan. We can have amazing hardware installed. But if client devices are not happy, we will spend a lot of time troubleshooting. What are the three main things that client devices do? Well, they like to think they select uplink data rates. The reason why it's with a star, because when uplink multi-user MIMO, the AP actually tells the client what data rates they should use. It makes roaming decisions, and my favorite is it randomly disconnects, and we don't know why, right? And hey, Jakub, help us. So yeah, good roaming makes users happy, and we had an amazing session about roaming today. Why do they roam? Let's think about this. Well, the most common one is you have too many APs that just scream at the client. Client doesn't know what to do, right? So the client might end up doing a ping pong between the clients, between the APs. There can be an AP-triggered event. So whenever RRM change happens, whenever DFS is being detected, access point will send a channel switch announcement. And now the question is, would the client device follow that channel switch announcement, or would it completely ignore and do whatever it wants? Then we have 11K, 11V, but again, we don't tell client, hey, move. We're telling, hey, you should consider moving. There's better AP. And of course, device movement, end user behavior. What happens every time we roam? Well, the client will go off channel most of the time. It will have to select what candidate to connect to and connect. And then it will have to derive the PMKs, the PTKs, so it takes time if you're not using a roaming feature, technology. Roaming is usually very complex to troubleshoot and monitor, right? So how many of you use something like that to figure out what's happening in your environment? Yeah, a lot of people. Yeah, we did try to make it a bit easier. So if you're a Meraki customer, you do have access to a lot of insights where we can actually look into the roaming patterns throughout the entire network and also what happens for a specific client device, okay? Also retrospective troubleshooting about those random disconnects and some random behaviors. Thanks to some of the partnerships we have with vendors like Apple, Samsung, Intel, we can actually get some extra set of data, put it into the dashboard, same happens on the Catalyst Center, and actually tell you as the end user, as the admin, hey, this device was sticky, or this device was disconnected because someone hit the Wi-Fi icon, okay? So, to revamp, we have three relationships, right, that we talked about, but there is one more. It's the end users, and it's how we interact with the devices, right? You can have the best design, you can have the best optimized client devices, but if the user doesn't know how to use it, yeah. So I'm gonna give you an example. Since this year, I'm a proud member of the Cisco Live NOC team. And at the end of the conference, we looked at the numbers, right? So in total, we had almost 15,000 devices connected to our networks. We have multiple SSIDs, right? So it's not only Cisco Live, WPA2 and WPA3, we have EduRoam and all the other ones. But let's focus on the WPA2, WPA3, okay? You can see that 1,000 6 gigahertz clients were stuck to WPA2, okay? So Cisco Live is considered a technical conference, so we have people that should know how to use the devices. I know people don't care about it because the guy I'm mentoring to become a wireless expert, he was stuck on WPA2 with all of his 6 gigahertz devices. And why is that important? We're talking about the benefits of WPA3. We're talking about from the security standpoint. We're talking about the benefits of 6 gigahertz, okay? Well, what actually those 1,000 clients missed out on is on 5 gig, at any point of time, the maximum throughput you were able to get was around 100, 140, right? And here you can see a nice real-life example of the uplink and downlink throughput, right? Because of the data rates and how well they can hear each other. If they're on 6 gigahertz, they would actually go much, much faster. and it's been an amazing experience. With all of that said, thank you so much for the 20 minutes I got. Yeah.